Hi students, how are you all doing? Let's study chapter light numericals for grade 10 board related questions. This is part 2 and I'm sure you have seen part 1 to understand the basic concept of chapter light. Now let us understand before we solve the light numericals. It's about sign conventions. Now, if you know coordinate geometry, you will understand the word Cartesian. Okay, so it's a new Cartesian sign convention. They are used for mirrors and lenses to avoid confusion in calculations. So there are certain basic rules which you have to remember, that all distances are measured from the pole or optical center. I repeat this again, students. Please, it's a request that if you write down these points along with. All distances are measured from the pole or optical center. Now, when we say pole, that's mirror. Optical center, we're talking about lens. Distances measured in the direction of incident light, that is positive. Distances measured opposite to the direction of incident light is negative. Heights measured above the principal axis is positive and heights measured below the principal axis is negative. This, if you understand the Cartesian plane, like how this side it is positive, negative, positive and negative. So that can be understood by using Cartesian sign conventions. Now let's understand the basic rules for mirrors and lenses. Students, this slide is extremely and utterly important if you want to do all the numericals. So it's a request again that you write down every single thing what you see here. If this makes sense to you, I'm very sure that you will not make any mistake in the numericals. So when we talk about basic rules for mirrors, light travels from left to right. Okay, that's assumed. Object distance denoted by U, always placed in front of mirror. That means U is always negative. Now let's take image distance. Now for image distance V, real image that is in front of mirror, it's negative. For virtual image, behind the mirror, and it is positive. So here we are talking about the image distance. This is the object distance. Then the focal length. Now we are talking about mirrors once again if I remind you. Focal length denoted by small f. For concave mirror it is negative and for convex mirror it is positive. Let's understand for lenses. Light travels from left to right. So object distance for this it's U, always negative. Object is placed on left side. For image distance V, real image right side, it is positive. For virtual image left side, negative. For focal length F, convex lens is positive and concave lens is negative. So you pause the video and request if you write down in your notebook once or twice, that will make complete sense to you. Let's understand what is magnification sign. Now magnification, the word talks about magnified. So M is equal to H slash upon H is equal to V upon U. Now here again as we are understanding the sign conventions. So when is M positive? When there is erect image. And when is M negative? When it is inverted image. Let's quickly understand some of the numericals that will make more sense to you related to sign conventions. So when you are solving the numericals, it's a request that you can keep all these sign conventions. You can refer it while you are solving the question. Question number 1. A 1 centimeter high object is placed at a distance of 2f from convex lens. So what is the height of the image formed? Now where is the object? It is at 2f. So when object is placed at 2f, image is formed at 2f on the other side. So image will be real, inverted and same size. So height of the image will be equal to height of the object, which is 1 centimeter. Let's take question number 2. Focal length of a lens is 25 centimeters. What is its power? Power will be 100 upon f. Now, focal length is 25 centimeter. Power will be 100 upon 25, which is plus 4d, that is diopter. So we'll be taking more questions on focal length as well. So these are the simple ones. You just have to substitute in the formula. Question number 4. Where should an object be placed for using a convex lens as a magnifying glass? Now let's take question number 4. Power of a lens is 0.4d. What is d? D is diopter. So what will be the focal length? Now students, we can use the formula f is equal to 1 upon p. So what is p here? 0.4. So 1 upon 0.4 is 2.5 meter. And you need to convert meter into centimeter, that is 250 centimeter. Focal length is 2.5 meter and you convert it into 250 centimeter. So 1 meter is 100 centimeter. So you multiply 2.5 into 100, you will get 250 centimeter. Okay, so 2.5 into 100, which is equal to this answer. Now question number 5. This is slightly a question which is mostly asked either in the short answer type questions or even sometimes in the MCQ part. Why does a stick partly immersed in water appear to be bent? Explain. So this is due to refraction of light. Now students, I'm very sure you know what is refraction of light. That is bending of light. So light rays from a submerged part bend when passing from water, that is denser medium, to air, which is rarer medium. So whenever the medium changes, there is some bending of light. This makes the lower part appear raised, so the stick looks bent at the surface of water. Coming back to the numericals, question number 6. Light travels from rarer medium to denser medium. Angle of incidence is given 45 degree. Angle of refraction is 30 degree. So refractive index of medium 2 with respect to medium 1, we have to use law. Which law? Snell's law, which is n is equal to sin I upon sin r. Please remember this, children. How it is being derived and all that. At present, you don't have to worry of it. Just remember this formula. So it is sine 45 upon sine 30. As in grade 10, you are doing trigonometry chapter, so you can refer those values. And there is also a way to understand those values or a particular, not the rote learning, but you can understand how to solve that or how to learn those trigonometric values. The same values we have to substitute here. We get root 2, that is approximate 1.41, which is the value of root 2. So you can give answer in 2 or 3 decimal places, 2 or 3 decimal places. Okay, which has been accepted by the board. Then you have refractive index of medium 1 with respect to medium 2. If you have to find out the refractive index, it's 1 upon 1.41, approximate 0.71 is the answer. So you need to be very good in the calculation because you will be needing it for your numericals. Now question number 7, we need to find the position, nature and size of the image of an object 3 cm high placed at 9 cm from a concave mirror of focal length 18 cm. Now here students, we have to use the mirror formula. 1 upon f is equal to 1 upon v plus 1 upon u. Focal length is minus 18 cm. You can refer the sign conventions. Magnification formula is v upon u. So when you calculate and put the values, you get minus 2. H dash is equal to m into h. Again, minus 2 into 3. That will give you minus 6 centimeter. What will be the position here? It will be 18 centimeter behind mirror. What is the nature? It's virtual, erect, and the size 6 centimeter magnified. Please remember, if it is magnified, that means it is behind the mirror. Question number 8. An object 4 centimeter high is placed 40 centimeter in front of a concave mirror. Very important that you need to read the question properly. It is where is the object? It is in front of a concave mirror. Focal length is 20 centimeter. Find the position of the screen for a sharp image. Again, which formula do we have to use? It's mirror formula. So just rearrange it. 1 upon V is equal to 1 upon F minus 1 upon U. Substituting the values, keeping all the sign conventions in mind, and when you will calculate, you will get V is equal to minus 40 centimeter. Screen should be placed 40 centimeter in front of the mirror. These questions, students, are utterly important. Request that you try practicing it more. Question number 9. A concave lens has focal length 15 centimeter. At what distance should an object be placed so that it forms an image at 10 centimeter? Find magnification. Now what is given here? Focal length is minus 15 centimeter. V is minus 10 centimeter. Using the lens formula, minus 1 upon 15 is equal to minus 1 upon 10 minus 1 upon U. Again, we need to substitute the values. But again, children, it's a request that you write down what is given first. So that will help you to understand while substituting the values. And when you calculate, you get U is equal to minus 30 centimeter. Also, we have to find the magnification here. So M is equal to V upon U. Substituting the value of U and V, you get 1 upon 3. So object distance is minus 30 centimeter and magnification is plus 1 upon 3. And what will be the nature? Virtual, erect and diminished. I hope this point is clear to you, and just pause the video and try doing it by yourself. Question number 10. A 2 centimeter tall object is placed at 15 centimeter from a convex lens. Which lens here? Convex. In the previous it was concave. A focal length 10 centimeter. Find the nature, position and size of the image. These three things, students, you have to remember. Nature, position and size is always asked in exam. What is the first step you have to remember? Write down what is given. Read the question well, write down what is given. Using lens formula, 1 upon 10 is equal to 1 upon V minus 1 upon minus 15. When you substitute all the values, you will get V as 30 centimeter. Now what is the magnification? V upon U. Again, substituting the values, finding out H dash is equal to M into H. You will get minus 4 centimeter. That is the size. When you have to find the size, you have to use this particular formula. So what is the position here again? It's 30 centimeter, which is the other side of the lens. What is the nature? It is real and inverted. And what is the size? 4 centimeter magnified, because it is at the other side of the lens. Question number 11. The image obtained with the convex lens is erect and 4 times the object. Focal length is 20 centimeter. Find the object and image distance. Now here, what is M given? It is plus 4. And what is the focal length? Plus 20. Because what are we discussing here? About convex lens. What is the magnification? V upon U. Now, if we cross multiply, you will get V is equal to 4 into U. So, after substituting the value of M here, using the lens formula once again, substitute the value and you will get the answer V as minus 60 centimeter. Now, what is the question asked, students? Object distance. It is minus 15 centimeter. Image distance minus 60 centimeter. But at the same side. What is the nature? Virtual, erect and magnified. Let's have a quick summary table for the questions what we have sorted. Quantity, if the object U, negative is the mirror sign. When it is mirror sign, it's negative, and lens sign, it's also negative. And if it is about the image distance, if it is real, it is negative. For virtual, it is plus. For lens, real plus, virtual minus. For focal length, for mirror sign, concave is minus, convex is plus. For lens sign, convex is plus, concave is minus. For height, if it is above, it is above, okay? So it is plus for mirror, and if it is below the axis, it is minus. For lens, if it is above the axis, it is plus, and if it is below, it is minus. So this is very, very, very important, and I'm sure the summary and the questions what you have done will definitely help you. So thank you so much. God bless you all. Keep learning, keep growing. For more informative and concept-based videos, very soon I will be covering more numericals related to different chapters of grade 10. So don't forget to like, share and subscribe. Thank you so much.